Okay, welcome to Geometry, Chapter 7, Section 3, and this is day 2. We are going to write proofs today, writing proofs with similar triangles. So we were using our knowledge of SSS, Similarity Theorem, SAS, Similarity Theorem, and AA, Similarity Theorem, and now we're going to use that to write proofs about similar triangles. So here we have given 3 UTs equals 5 RTs. And we have 3 VTs equals 5 STs. So can we prove that triangle UVT is similar to RST? We can prove, and how do we go about proving it? So you can see on the next slide you have 6 steps. So the first step we always know is first step of
given
proofs.
information.
Okay, so how do they state the given information? They begin with 3 UT equals 5 RTs. Given. Usually when they only give one piece of the given information, something flows out of this before they give the other given, right? We also know the last step, of course, is going to be that triangle UVT is similar to triangle RST. Okay, so if you know that 3 UT equals 5 RT, 3 UTs equals 5 of these. Could you figure out like what RT equals, or UT?
Well, can't the 3...
Well, could you give an expression for it? Like, for instance, what does UT equal? If 3 UTs equals 5 RTs, what does just plain old UT equal?
UT equals 5 over 3 RT.
5/3 of RT.
Yeah.
Good. And how about this? What does VT equal?
3 over 5.
5/3.
5/3. That's kind of interesting.
1 2/3.
Okay. So, is that where they're going from here? Aha.
Most likely.
Divide both sides. In this case, they divided both sides by, interesting, by 3 RT.
So double cancel. Because they take the 3 over there and then the RT over there.
That gives you a proportion, 2 sides. How is UT related to RT? 5 to 3. And so the goal of similarity is to find proportional sides, right? That's one thing we could do. So what do you think they're probably going to give next?
Something given information.
The other given, which is what we were just looking at, right? And so there it is. 3 VT equals 5 ST, the other given. Now, don't say it. How can you form, what will we divide both sides by? Stephen.
3. False.
Wait a minute. Don't you want to get the 5/3 by itself? So we would divide the 5 side, the side that has a factor of 5, by what in order to get 5/3 over here?
ST.
We'd have to get ST out of there and 3, right? Isn't this interesting? It's not dividing by a factor that you see. It's one that you're coming up with. If you divide both sides by 3ST, you end up eliminating the ST from the right side, and you see that this proportion also equals 5/3. Okay, so we have 2 pairs of proportional sides. We have RT as being proportional to TU, UT, and VT with ST. They have the same proportion, 5/3. What else might we need to prove this? We don't have an SS. So we need what?
Angle.
We need an angle.
Those are
So,
vertical angles.
vertical angles. Good job. So we could call this one RTS or STR.
STR.
RTS.
They call it RTS.
Okay.
It doesn't matter. Name it what you like as long as it's true.
Aha.
And that's vertical angles theorem. So the final step is we have triangle UVT similar to RST, and we found it with which theorem?
Wait. Let me write this.
SAS. Good. That was the gleeful response for the completed theorem. Brought to you by Alyssa. Okay,
Scream for no reason.
check it out, example 4. Here we go. Given M is the midpoint of JK, N is the midpoint of KL. and P is the midpoint
Oh, it's
of
this
JL.
Mid-segment triangle.
yeah. That's what
Okay? You know what I did on this when I left these statements there? You just need to give me the reasoning
Thank you. Let's give
to
him.
make this move a little faster, and then you can practice on the quiz. So the given is, we have all these midpoints. So our first is given. Now see if you can complete step 2.
What
Look at
choice
step
was-
2. And Amaya, why do they say that MP is half of KL
Definition of midpoints.
and MN is half of JL?
Oh, definition of mid-segment.
That's a midpoint.
Mid-segment theorem. Go look at what they're identifying here.
Oh, you're saying midpoints.
Go take a look at what they're saying. Okay, so we have MP is half of KL. So MP to KL is equal to MN, which is half of JL, MN to JL, which equals NP to KJ, which all equals 1/2. And what is the reasoning, Joey?
I just said divide by KL, JL, and KJ.
Okay, division, property of equality, good job. So because they all have this equivalent ratio, 1/2, what would the reasoning be for their similarity?
It's
SSS.
Good job,
That was
SSS.
too many S's.
SSS, good. Alyssa, having parents who are engineers, will walk us through this engineering application.
Okay, so the picture is a gable roof.
That's what that's called, a gable
Okay.
roof, like a V.
I thought that was like an A. Okay,
Just give it half.
Okay, so AC is parallel to FG, and triangle ABC is similar to triangle FBG, and we have to find BA to the nearest 10 of the segment.
Segment
So-
BA, good.
So we'll probably set up a proportion because we know that they're similar, and
How would you set it up?
I would set it up 6.5 over 24 equals. Wait a minute. Is the 17 saying like the whole line there is
No.
17?
No,
Or is it just
no.
that little part?
That's what we're solving for.
Okay.
Come on.
Sorry. Well, let's
Oh, I know.
how do you
I
You
know.
take
Okay.
17 minus x
No,
below
17
plus
minus
plus
17
plus x
That's this whole
below
AB.
x.
No, 17. Okay, so x over 17.
That's
There you go.
Just
There we go.
said.
Okay, so she's saying we have an unknown BF,
You stole her thunder. Not cool.
Yeah, I know.
and so the long segment AB is
Is
17 plus X, and the short segment
is x.
is X.
So then we would let's do cross product.
Yeah, let's.
So 6.5 times 17 is.
Oh, calculator.
Oh, I already done it.
I'm going to write the proportion that you
is
gave us,
110.5
6.5 over 24 equals X over 17 plus X.
Plus 6.5x equals 24x.
It's
So
minus 6.
So tell me what this
Yeah.
equals when you
So
multiply this by
subtract
6.5.
6.5.
Alyssa,
Yeah,
6.5 times 17
Oh, that is 110.5.
plus
Wow.
6.5X equals
Equals-
24X.
And then we subtract
Oh, wow.
6.5x. And we get 110.5 equals, 7.5x.
Wait, 24 minus
Sorry.
6. 24 minus 6?
No, there's a 0.5.
I know, but 7 doesn't make any sense. 18
Oh,
minus
sorry,
half.
I
sorry.
increased it.
Okay. Yeah, it's 17, sorry. 17.5. I wasn't
I increased it so
Okay, and then you divide all of it by 17.5.
And
Which
Joey
is-
says blow it up by factor 10, which is a good idea.
That was
I want
probably
two.
a smart idea. Okay.
And what do you have? What
It's,
does X
Well, that would
About
be
6.3.
Melissa.
That's what I
Yeah.
got.
Oh,
About 6.3 feet.
it's like 6.3 feet.
Okay,
about.
but now let's go back and see what the question was. Were we to find BF, Alyssa?
We were to find BA.
Ooh, okay, so we don't, it's not 6.3, is it? It's,
No, yeah,
it's-
yeah, it
17
is.
plus 3.
No, it's not an AM.
Oh, wait, I thought we were finding BF.
False.
Yeah.
It's 23.3 feet.
Yeah, it's
there you go.
23.3.
23 point feet. Don't forget to answer the correct question, right? Very good. Okay, good job. That was good. And we're going to skip over that. And we're going straight
You're
to
welcome.
this properties of similarity. So let's read this over together. You learned in chapter 2 that the reflexive, symmetric, and transitive properties of equality, excuse me, Joey, have corresponding properties of congruence. These properties also hold true for similarity. So we have a reflexive property of similarity. Triangle ABC would be similar to triangle ABC. Triangle symmetric property of similarity. If triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. That's our symmetric. And then transitive, which is my favorite. Triangle ABC is similar to DEF, and DEF is similar to triangle XYZ. Then triangle ABC is similar to triangle XYZ. Transitive. Okay, so go ahead and try this quiz. Come back and check your answers. Okay, Stephen's explaining number 1, and he says due to the fact that it's isosceles, the base angles are congruent. So we have 70 here, and C is 70 as well.
And then B is 4.
So he says B is 40.
And then I can use SAS.
So we can use SAS. Excellent. What else could
Oh, no,
you?
you can't
Actually,
use SAS.
we can't use SAS because we don't know those side lengths, do we?
False.
What did we say the other moment at the beginning of this lesson when we knew
No.
70? If we know 70, 40, what could we say about P and R?
74.
No, I used A.
Or sorry, 70, 70.
Yeah.
I think it's better to say AA,
That's
isn't
what I
it?
did.
Because
Yeah.
we know the angles, but we don't know the side lengths, right?
I'm just
But can't, since the sidelines are congruent on those, then can't you say the proportionals?
We don't know their length though, so we can't use that.
So
We can't, we actually know the degrees of those angles, but we don't know the lengths of these sides. So let's go see what the key says. Of course, the key we can't trust, but anyway.
No, but you can trust the key.
What do they say? AA. Okay, we trust them on this one. It's AA because we know the measures of these angles are the same. Okay, how about number 2? Joey, can you explain why the triangles are similar?
Okay, so by using all our theorems and stuff about parallel angles, angle E is corresponding, well, AEB is corresponding to angle D, so they're congruent. And then angle ABE is corresponding to angle C. So they are congruent. So then you can use,
So which of the theorems are you using for similarity?
okay, so AA.
AA,
And
good.
then 3 over 4.5, and then I'm going to blow it up to 9 over 6. And then,
Wait, did you say 3 over 4.5?
oh no, no.
What?
It's 3 over 7.5.
Very good, 7.5.
15. 6
So
over
he wants to
15.
blow this up to be 6 over 15
And then
to
you
get
can
rid of that?
divide it to 2 over 5. So it's simple. And then you
Oh
can,
yeah, 2 over.
2 over 5 equals x over x plus 6, and then cross products 2x plus 12 equals 5x, and then 3x equals 12, and then x equals 4. So BE would equal 4, and then CD would equal 10.
Good job.
Yeah, that made
Okay,
lots
so
of
we
sense.
find x and we plug it in, 4 and 10. Good job. Have fun with that.
Good job.
Here's your assignment.